A technician is commissioning a packaging line where a proximity sensor is supposed to detect a metal can and trigger a pneumatic stamping cylinder. The system uses an Allen-Bradley CompactLogix PLC. When a can is placed under the sensor's built-in LED indicator lights up, confirming detection. However, the stamping cylinder does not extend. The technician checks the PLC and sees that the run light is solid green, and the input LED on the PLC card corresponding to the sensor never turns on. Which of the following is the most likely cause of this issue? A. The pneumatic solenoid for the cylinder is faulty. B. The proximity sensor is a PNP sourcing type, but the PLC input is wired for an NPN syncing sensor. C. The logic in the PLC program for the stamping cylinder is incorrect. D. The air pressure supplied to the pneumatic cylinder is too low. The most probable cause is B. The proximity sensor is a PNP sourcing type, but the PLC input is wired for an NPN syncing sensor. The key to this problem is that the sensor's own LED is on, but the PLC's input LED is off. Sensor LED on. This confirms that the sensor has power and is correctly detecting the can. The sensor itself is working. PLC input LED OFF. The PLC's input card is not recognizing the sensor signal. This classic symptom occurs when there is a mismatch between the sensor's output type, PNP/sourcing versus NPN/syncing, and how the PLC input card is wired. A PNP sensor sources or provides a positive voltage signal. If the PLC input is wired to sync the signal to ground, expecting an NPN sensor, it will not correctly detect the high state from a PNP sensor. Therefore, the PLC program never receives the signal to activate the stamping cylinder. The other options are less likely because if the solenoid were faulty, A. The air pressure were low, D. Or the logic were wrong, C. The PLC's input light would still turn on when the sensor detected the can.